All right, here we go. Our first taste of the nice derivative rules that we're going to be looking at. So, the power rule. This tells us how to differentiate a power function. So if we have a function x raised to the power r, then the derivative is r times x raised to the r minus 1. So first of all, what we're differentiating here, f of x, x raised to the r, this is a power function. It's just x raised to an exponent, x raised to a power. It's a power of x. That's why it's called a power function. And it's important just to kind of consider what's going on here with this power function. So the base term here is, that's where our variable is. So the x here is kind of on the main level. That's the base of this power function, and it's our variable. The exponent, what's going on up here, this is a constant. So this is just kind of important to kind of keep track of where the variable is and where the constants are. So if our variable, if we have a power function, there's a base term and there's an exponent. If the base is a variable and the exponent is a number or a constant, then we can use this power function. And the way this works is a lot of times we can think of this as more of like a kind of a little three-step process. So if we were presented with this power function, what would differentiation kind of look like? I mean, you could just remember the formula. But the way I think of it is almost like a three-step process. So I take this exponent, our old exponent, kind of pick it up, and I throw it down right in front of everything. So I'm going to have f prime of x is equal to r. So I take that old exponent, put it in front. Then I keep the variable the same. So we were using an x here. I'm going to keep using an x over here for our derivative. And then I subtract 1 from the exponent. So I get r minus 1 up there. So kind of the 3 steps here. Step 1, I bring down the old exponent. And put it in front. Step 2, I keep the variable the same. So if our derivative, or if our function is using x, then our derivative is going to use x as well. And then the third step is I subtract 1 from the old exponent to get my new exponent. So r minus 1 there. It's just a nice little process here. All right, so let's try some examples. So we're going to calculate the derivative f prime for all these different functions here. X squared, x cubed, square root x, 1 over x. We're going to be able to use power rule for all of them. So let's start with the first one. Let's see how this works. So we're going to calculate f prime of x. And it's a power function, so it's x raised to a number. It's actually just a power of x here, x squared. So how does this work? Well, we're going to take this old exponent, which is 2, put it in front, keep our variable the same, and then subtract 1 from the exponent, so 2 minus 1. Do the subtraction, we end up with 2 times x raised to the power 1. And kind of being a little silly here, we don't normally write x raised to the 1. It's kind of understood that that 1 is there. So we would just write this as 2x. All right, so there's our derivative of x squared. The derivative is 2x. Notice how much easier that is, how much quicker that is than going back to our limit definition of derivative and going through setting up the difference quotient, calculating the limit. This is going to really kind of quicken things up a little bit in terms of how we calculate these derivatives. Now what about f of x equal to x cubed? Let's differentiate this function. So derivative is going to be f prime of x. The old exponent is 3, so let's take that 3, bring it down, put it in front, keep our variable the same, so x, and then we're just going to subtract 1 from the exponent, so 3 minus 1. Do that arithmetic, we get 3x squared. So 3 minus 1 is 2. And there's our derivative, 3x squared. Now, we're kind of showing a little bit more here than what we in practice normally would. So this step and this step here, we don't normally show this. Perfectly fine if you want to. And as you're just kind of getting used to using the power rule, it's definitely fine to do this. But normally, for these type things, once you get the hang of calculating derivatives like this, you'll probably just go right from this function right to the derivative. So not too much work to show for these using the power rule. But if you want to show this step, perfectly fine if you want to. And sometimes it's helpful, as we might see from the next two, because sometimes that exponent can be a little bit trickier. So in this third one, we have f of x equal to the square root of x. And as it's written right now, it's not really written in the right format to differentiate. So, the root function looks nice, but it's usually helpful to try to rewrite this where there's an explicit exponent. And so this is going to be kind of a recurring little strategy that we use. We want to rewrite any root functions that we see. So in general, we might see like the nth root. We want to rewrite that as raised to the power 1 over n. So the nth root would get rewritten as raised to the power 1 over n. In this function here, it's the square root, so that's like a little 2 here. So the square root would get rewritten as x raised to the 1/2. So we want to rewrite any root functions that we have as an actual power function. All right, so now this is a good format. We have a number in our exponent, so now we can just use the power rule, which says take this old exponent, which is 1/2, bring it down, put it in front, so we're going to have a 1/2 there. Keep x the same, so keep our variable the same, and then we're going to subtract 1 from the exponent, so 1/2 minus 1. And if we do that subtraction, we end up with x raised to the negative 1/2. And this is perfectly fine if we want to stop here. And actually, in a lot of cases, we might be interested in doing like the second derivative. So a lot of times this is a good place to stop. But if needed, we could rewrite this. We could go back to root functions. So the negative exponent here, we could rewrite that as what the negative exponent does is it just kind of is a reciprocal almost. So we could rewrite this as 1/2 times 1 over x raised to the positive 1/2. And then x raised to the positive 1/2, that could take us back to the square root. So we could we could rewrite this as 1 over 2 square root x. Another way, if you wanted to kind of simplify down the function, you could go this way. And sometimes it's helpful to try to rewrite it back with the root function, back with any fractions that you have, because we might be interested in where the function is undefined. So what is the domain of this derivative? I think it's easier to find from this fraction. We can't divide by 0, can't have negatives under the square root. It's easier to miss things like that when it's, this power function format. So there's benefits to leaving it with the negative exponent and the fractional exponent like this, but there's also benefits to kind of rewriting it, back closer to its original form. All right, but this is our derivative. Little kind of discussion there. What about the next one? The fourth one here, f of x equal to 1 over x. So this is going to be another one of our little strategies that we do. Right now it's not written as a power function, but our strategy is to rewrite this with a negative exponent. So we're going to rewrite using negative exponents. So there's a little bit of preliminary work here. we got to rewrite our function so that we can use the power rule. Right now, the power rule doesn't apply. But if we were to rewrite this as x raised to the negative 1, so there's always a 1 there, and the reciprocal is like having a negative in the exponent. So we can rewrite this 1 over x as x raised to the negative 1. And so calculating the derivative, we're going to get f prime of x. Now we're using this power function format, so we're going to bring down our old exponent. Make sure that's a clear equal sign. So we're going to bring down our exponent, which is negative 1. Keep our variable part the same. We're going to subtract 1 from the exponent. So we had a negative 1. Now we're subtracting another 1. So we end up with negative x raised to the negative 2. And that's our derivative. Perfectly fine to stop there. And a lot of times that's where we should stop. Especially if we wanted to, say, calculate the second derivative, this is a good format to do that. But sometimes we might be interested in kind of rewriting this back as a fraction. So how would that look? Well, it would be negative 1 over x squared. So instead of x raised to the negative 2, it's just the reciprocal of 1 over x raised to the positive 2. So also fine to rewrite it as that. All right, so just getting a little practice using the power rule here.